In this video, we're going to talk about a cone's area and volume calculations. We already have an example on the screen, but before we start, there is a basic information you need to know about cones to be able to solve problems around cones. Say we have a cone. Now, in the cone, the bottom side is kind of circular, so that means that it has a diameter and it also has a radius because it's circular. Now, we call this radius most times the base radius. Since the cone is a 3D shape, it has a height. From the tip of the cone to this point is a height. This slant line like this is called the slant height of the cone. If you notice, this is a right angle triangle. So that means there's a relationship between this, and this. And that is the slant height square is equal to the height square plus the radius square. Whilst the curved surface area of the cone is giving us equal to pi RL, and then the volume of your cone is giving us 1/3 pi r square h. So these are the three important formulas that we're using again and again if you're going to do volume and area calculations of a cone. Let's jump into the question on the screen to see this in action. For the first example here, we're told to calculate the curved surface area of a cone whose height is 8 centimeters and the base radius is. So I'll first write out solution. Now the next thing I want to do is to dig out my given values. And we are told to calculate the curved surface area. So that tells us that we are finding the curved surface area. And then we are told that the height of our cone is 8 centimeters. So I'll write height is equal to 8 centimeters. And then we are told that the base radius is 5 centimeters. And then I'll write R here is 5 centimeters. The curved surface area of a cone, like I stated before, is giving us A is equal to pi RL. So we can use this formula to find the curved surface area of a cone, but the problem is that we do not know the value of L. So we have to first find the value of L. So to find the slant height, I'll say for L, you can use the formula I showed you earlier. So that you have L square is equal to R square plus H square. L square is equal to, now substitute these values into this equation. So that I'll have 5 square here plus 8 square. And then this is L square is equal to 5 square is 25 plus 8 square is 64. Here I have L square is equal to 25 plus 64 is 89. Then to get my value of L or my slant height, I have to take the square root of both sides. So that L square, I think the square root of this is equal to square root of 89. This cancels out this. L is equal to square root of 89 is equal to 9.43 to 2 decimal places centimeter. Since I have found my value of L, I can now use this value to calculate the curved surface area. So I will say for curved surface area, my area will be equal to pi RL. And then my area is equal to pi. I'll use the value of pi as 22/7 here. So this will be 22/7 times the radius I was given is 5. So this is times 5 times the slant height is 9.43 from this calculation. So I'll say this is 9.43. So that this is area. If I multiply all the numerators, I have 22 times 5 times 9.43. And then dividing everything by 7. The curved surface area is equal to, if I say 22 times 5 times 9.43, I get 1037.3 divided by 7. So that the area is equal to 1037.3 divided by 7 is 148.19 to 2 decimal places. And then the unit is centimeter square. Let's look at extra examples. So for another example, we are told to calculate the volume of a cone of 15 centimeter diameter and 25 centimeter height. Like before, I write out my solution. and then I pick out my important given values from the question. So the question tells us to calculate the volume of the cone. So simply, this means that we are finding the volume of the cone. And the question tells us that the cone of 15 centimeter diameter, that means the diameter of our cone is 15 centimeter. And it has a height of equal to 25 centimeters. So like I said before, to calculate the volume of the cone, we can use the formula of V is equal to 1 over 3 pi r square h. Now from this formula, we have our value of h given, but we do not have our value of r directly given. So we have to find it. So I'll say for r, now we can find r from the diameter. So the radius is half the diameter. So I'll say diameter over 2. Now the diameter here is 15. So this is simply 15 divided by 2, which is equal to 15 divided by 2 is 7.5 centimeters. So let's calculate my volume. I'll see for volume. My volume is equal to 1 over 3 pi r square h. So I'll plug everything into this formula, and then this becomes V is equal to 1 over 3 times my value of pi. I'll use 22 over 7. So this will be 22 over 7 times. For my radius, I'll use this value here. So this is 7.5 square times my height is 25 centimeters. So that for my volume, I'll multiply the numerators here, and then this becomes 22 times 7.5 square times 25 divided by 3 times 7. My volume is then equal to my numerator. If I do 22 times 7.5 square times 25, I get 30,937.5 divided by, now for my denominator, if I do 3 times 7, I get 21. So that my volume here is equal to 30,937.5 divided by 21. So my volume is equal to 1,473.21 centimeter cube. So that's the volume of this given cylinder. Now let's take one extra example in cone and volume calculations. So for this one, we are told that a cone has a slant height of 8 centimeters and curved surface area of 150 centimeters. Find A, the base area of the cone, B, the perpendicular height of the cone, C, the vertical angle of the cone to the nearest degree. In case of you want to have a go, you can pause the video and try to solve this one yourself. So before I solve, this is the solution. The given values is, we are given the slant height. So this is L is equal to 8 centimeters. We're also given the curved surface area as 150 centimeters. So that means the area is equal to 150 centimeters. For A, I told to find the radius of the cone. So how do we find the radius? The formulas we have on our hands is that area is given as pi RL. So from this formula, we know the slant height, we know the area, and we know the value of pi. So we can use it to find the radius. So that from area is equal to pi RL, we can make R subject of formula. So that here, if we divide both sides by pi L divided by pi L here, pi L cancels out themselves, and then R is equal to area divided by pi L. So that if I substitute everything here, we have R is equal to, area is 150 centimeters square. This is square. So this is 150 divided by pi is 22 over 7. So we have 22 divided by 7 here times the slant height is 8. So that the R is equal to 150. Then if I do the denominator, 22 times 8 is 176 divided by 7. So that this is equal to 176 divided by 7 is 25.143. So that this is equal to, if I say 150 divided by 25.143, I get 5.97 centimeters to 2 decimal places. For the second problem here, we are told to find the perpendicular height of this cone. So that means we have to find h. Now, between what we know and what we don't know, we know that h can be found using the formula of L square is equal to h square plus r square. Now, from this formula, we know the value of r, we know the value of L. So that making h square separate the formula here, we know that h square is equal to L square minus r square. And then if we take the root of h to make h separate the formula, we say h is equal to square root of L square minus r square. So using this formula, we can get the value of h. Let me clean up space so that h here is equal to square root of L square is 8 square minus r square is 5.97. That is 5.97 square. And then h is equal to square root of 64 minus 5.97 square is 35.6409. So that h here is equal to square root of 64 minus 35.6409 is 28.3591. So that if I take the square root of this number, I'll have h as equal to 5.33 centimeters to decimal places. And then for my last question, I'm told to find the vertical angle of the cone. Let's call that vertical angle alpha. Okay. Now I'll clean up space before we solve this one. Before we solve the vertical angle, I want to really understand what the vertical angle of the cone is. If we have a cone like this and we have our height here with our radius, this is our height, this is our slant height. The vertical angle is simply this angle, this is our radius. So how do we find this angle? Now if you notice, we have an angle here for this is the slant height, this is the height, this is the radius. So we have an angle here. Let's call this angle theta. Now if this angle is theta, we can find this angle, but this angle is not exactly this angle. If you call this entire angle alpha, that means alpha is equal to 2 times theta. So how do we even get theta? We can get theta using SOHCAHTOA here because this is a right angle triangle. So to get theta, I can use sine. If I use sine here, the opposite is radius. So I can say sine theta is equal to opposite, which is r, divided by L. So that I can now say theta is equal to sine inverse of r over L. So that from here, I can say the vertical angle is 2 times sine inverse of r over L. So that's how to get our vertical angle of a cone. Now let me clean up space. So for a vertical angle, I'll now say this is equal to 2 times sine inverse of the radius is 5.97 divided by the slant height is 8 centimeters. So that this is alpha is equal to 2 times sine inverse of 5.97 divided by 8 is 0.74625. So if I take sine inverse of this number, I have alpha as equal to 2 times sine inverse of 0.74625 is equal to 48.2666 to 4 decimal places. So if I multiply 2 times 48.2666, I get my alpha as equal to 96.5332. If I approximate this to decimal places, I have alpha as equal to 96.53 degrees. So that's it. That's the vertical angle of my cone. That's how to solve area and volume problems in a cone. If you like the video, give it a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.